Hello again. So in that video, we're gonna look at the main function and the core function of our project. So we saw in a previous video, we put the video stream in the canvas here. So because of this, we'll be able to manipulate the pixel data in it. So let me first create a new folder. Yeah, I guess I can create a new folder. Call it utilities, and in that I'll create a main.js file. Right. So there's two things we need to know before manipulate the pixel data. Is first the RGBA model. So the RGBA model, it's a color model which consists of dividing every pixel in four values: the red, green, blue, and alpha values. So RGBA stands for that. Because every pixel will have a combination of these four values and determine what the pixel actually is. So depending on the combination of red, green, blue, and the opacity, we'll have a different color. So that's the first thing, and then we need to see on the canvas the methods that are important for us. So we saw before all this available method we have to draw stuffs on the canvas, on the context, sorry, it's an easy word. We have three methods that matters to us here. It's put image data, get image data, and create image data. So I already selected get image data. So the definition is very clear. It returns an object representing the underlying pixel data for a specified portion of the canvas. So that's exactly what we need to manipulate the pixel data, is to get the actual data. So what we're going to do in the code is we can create a variable called current frame, and we're going to call that method on the context, get image data. We need to provide the top left coordinates and the width and height we want, so we take the whole canvas, and we can simply console on get first place. So instead of putting this every frame, every 60 milliseconds, we're going to do it every 2 seconds so that my browser doesn't complain too much. Let's see. I'll refresh that. Get camera, get canvas, and so we have an object here. So it's an image data object. We get the width and the height that we specified, and a data object in it. So this data object is a typed array, a very big one, of 120,000 values, if you count the 0, of course. So why is that? If you take the calculator, we have 200 pixels for the width, we have 150 for the height, and since it's an RGBA model, we get 4 values for each pixels. So we multiply this by 4, we get 120,000. So this is indeed all the pixel data, but if we open this, here we see like the red, green, blue, and opacity of the first pixel. The first pixel that is on the top left corner in my canvas. So we have like a simple list, I mean it's an array, of all the values of the canvas, of the pixel data from the canvas. So it's a lot of values. So what matters here for us is the color. If I have this charger here, and if you put that charger on the bottom right and look at the pixel data at that moment, so maybe let's wait. I think it's at the bottom now. So if I open that data object, and go towards the last values, because it goes from left to right, and so this should be the data from the bottom right, and see all is at 255, because my charger is very white, so the red, green, blue values, they're all at the maximum, which corresponds to white. If I take something black, I got a ball, I didn't prepare it, I swear, it was there. If I put it on the bottom right here, and if I open the current frame, so let's wait. If I open my data object and I go to the bottom right values, I open that. So see, the RGB values, they are close to 0. It's not exactly 0 because it's not exactly black, but that's the idea. If it's black, it's very close to 0. If it's white, it's very close to 255. And the opacity is always the same. So, what we want to do here is comparing all the frames. We want to compare all the frames, and we want to it's not all the frame. We want to compare the current frame with the previous frame, and we want to check if there's movement, like between, if the movement has been done between these two frames. So the idea is, if you have movement, you will have a very big change in the pixel data. So if you compare these two frames, and if you subtract the pixel data of these two frames, there's a big chance that the difference in the pixel value will be big. So if you subtract these two values, all these values, all this corresponding value, the difference will be will be big, so the subtraction will be closer to 255. If there's no difference between the frames, if you subtract two very similar frames where there are no movement, the pixel data will be the same, and if you subtract the values, they will be cancelled, because here you will have the same kind of value, and if you subtract a similar amount, then it will go close to 0, and it will be black. Meaning that the more movement, if we subtract the two frames, the frame, the corresponding subtraction, will give a white values at the place where there's movement, and black values, black colors, at the place where there's no movement. It's not very clear, but let's write a function and it will get clearer, I hope. So let's call that name. So we need to provide three things. We need to provide a blank object. We need to have the previous frame and the current frame. We have two frames, so the previous one and the current one. We want to subtract it. We subtract the current from the previous, and put the result in the blank. So basically, I'll call that P, and current. So this will be B equal P minus C. That's a simple subtraction. I need to do that for every values of the RGBA model. So I need to do it 4 times, except the last time, because it's the opacity, we just set it to 255 anyway. It's a set of 4 values, so in the data object I actually need to get the I, and first is the first pixel, this is the second one, and this is the second, and this will be Yes, sir. First I could have mentioned that this data object is a typed array. If you look at the prototype, you don't have much methods on that. You have the lens, and then you get the object. So meaning we won't be able to do too much things. So we're just going to use a simple loop here. So we're going to loop on all the typed array. So let's create it. We're going to go until these three objects, the blank objects, the previous frame, and the current, will have the same size. Okay, so you can simply take the one that is blank, that we'll create later, and e plus 4, because we go every 4 frames, and this is the size. And we get a loop here. Okay. All right. So by doing this, and here we do a plus plus, of course, and we return the blank object. So we provide a blank object, the previous frame, the current frame. We subtract the current frame from the previous one and put it in the blank object. And at the end, we return the blank object. The opacity will be always the same. The first value, we subtract only the values of the previous and current frames for the red, then the green, and then RGB, and then the blue. All right. And we do this every 4 pixels. So that should work, I believe, except that this divided by 4. All right. Do we get an error? I can remove that. No. Refresh. Okay, so no error, which is good. So well, we're going to need to call our method. So I'm going to need to import it first. Import name from its utilities and its main. Okay, and here we need to export it. So BPC should do it. And so we need to provide a blank object, a previous frame, and a current frame. Okay, at the moment we only have the current frame. What's the blank? So the blank, we simply need that method called create image data. So what does it does, it's create a new blank image data object with a specified dimension. So we just need to specify the width and the height. So that's very simple. On the context, create image data, the width and the height. We can just have a look at it. Blank. Get camera. Main is not defined, yes, of course. So if you look at that, the data object, so it's the same size, and normally if you open it, it's all 0. All right. So Yes, one error, I know, because I called that main, and so I need to call that main here. All right, we got our blank data object. We get the current frame, and we need the previous frame. Because each time we're going to run this function for each frames, which means we're going to run it every 16 milliseconds. So each frame, each time we run it, we'll need to have the previous frame available somewhere. Because each time we create an image data object, and that corresponds to the current frame, but we need to compare it to the previous one. How do we store it? Then we're going to simply use the local state of React and call that previous frame. And at the moment, there's nothing. If there is nothing, so if is this the state that previous frame equal null, then we'll have to fill it with the current frame. So previous frame is current frame. So if this is empty, if this is null, meaning there's no previous frame, meaning here the current frame is the very first one, if we are in that case, then we set the state to the current frame, because the first current frame will become, at the next one, the previous frame. All right? We can imagine that after we run the function, we'll have to do this again. All right? If it's in the case that there's nothing, the first frame, then the previous frame is the current frame. If this is not the case, then at the end we'll need to do it again. Okay? But maybe this is too soon. So we get that. So if we run our function, we'll have the blank. The previous frame is actually what's in the state. So this is the state that's previous frame. That won't be null. That will be the current frame. And the other one is the current frame. So that should work. So if we run this, actually we need to provide the data object, because if you remember, let's do this again, just to be extra clear. If you look at that, blank is actually the image data, but what we need to provide to our function is the data object, So it's a typed array, because if you don't provide everything, that it is not going to work. Because in our main function, we just manipulate the pixel data. So in our function, we need to provide the data object only of all this. Yeah, I guess we can do it like this. So once we run this, we're gonna return a new blank object, but this blank object won't be blank anymore. It will contain the subtraction of the previous frame by the current frame. I don't know how to say it, or the current by the previous. Once we have it, we will need to put it back to the canvas, that blank data. That won't be blank. We need to put it back in the canvas, and we're going to use that method called put image data. So this is also straightforward. This method spans data from the given image data object onto the canvas, and you need to provide the image data and the dimensions. So it's as simple as create image data and get image data. So it's on the context, obviously, and you put image data. What's our data? It's blank.data. That's not blank anymore. The width and the height. And we need once we do this, we need to set the current frame to the previous one, because if you don't change that, then you will compare always with the very first frame. So we need, even if it's not the first one, we need to set the previous frame as the current frame before the getCanvas function is run again. So that should work. Let's see. Move that. But image data parameter is not of type image data. Oh, this is because in that case he wants the full object. So this is not working because maybe I need to provide 0, 0. Okay, here you go. So I'll change the 200 by 16, so which is like each frame as it should be. Yeah, I need to fix that out. Doesn't matter. Get camera, get canvas. Okay, so now you see at each place I move, it appears white. All the rest appear black. Why? Because our function subtracted the previous and the current. So if, as I tried to explain earlier, if this is, for example, very close to 255, and this is also very close to 255, we can assume that the pixel data is similar, so there's no difference between the two frames, there's no movement. So that difference is going to be very big because you subtract this by 250 by 250, so it's going to be close to 0. If meaning close to 0 meaning black, so what you will show here is something very black because there's virtually no difference between the pixel data. So if you subtract one pixel data from a frame from the other one that was the same, then the difference will be almost 0. So this will appear very close to 0. If I move, the pixel data will be very different. So let's say I would have like 250 here, and I would have maybe 20 or 30, but it doesn't really matter, meaning that the subtraction will get 250 minus 20, for example, so we'll get 230 for that value, which will be close to white. And indeed, if you go close to it, it's not all white, no? You can see there's like some green, some red, whatever colors. The idea is like it's close to 255, so it will be close to white. And as you see, it's enough to see some whitish stuff where there is movement. In the background, nothing happens, it's all black. If I move only my nose or my ears, you see, it's my ears. All right. However, I should probably use the map apps here, because in case one is negative, we only the difference matters here, and that should be it. So yeah, I'm aware that this is probably not the most optimized version, because maybe you're asking a lot of calculation to the browser, but yes, maybe you don't need to calculate if there's no difference, so that the function doesn't have to run that often. Maybe that can be optimized, but I think it works pretty well. You draw on the context each time you run on a function, but I think that's also good. Canvas is pretty performant, so that should do it. All right, so that's it. We got our movement detection almost set up. That's all for that video. I hope it was not too confusing. It probably is, but at the end, it's just comparing frame. If you have a big difference between the two frames, you show it black, and if there's no difference, you show it black. If there's a lot of difference between the frame, meaning movement, you show it white. So in the next video, I'll show you how to put some visual aids on the canvas so that we can have some frame to move in the right place in front of the webcam. Thanks for listening, in case you've been that far, and see you in the next video.